All right, let's make a microservice. Please welcome Michael to the stage.
Okay, so a little bit of background. I've been primarily a Node guy, JavaScript, React. I've been doing Ruby for about 4 months. But I was excited to see that the last part of the last couple months of 2018, AWS opened up their native Lambda runtime to include Ruby. So that was cool. So this is a little bit of my work going through and some of the stuff that I figured out and some of the stuff that, I don't know, has anybody gone over to AWS, the Loft, where they'll give a free help desk, which is actually pretty awesome, up to an hour. But actually, I went over there once, and I think I actually stumped the guy at their Genius Bar. But we'll get into what kind of led into that. So they were talking about microservices, which is a architectural pattern for deploying applications. And so this is kind of, at least shows a little bit of, traditionally, we'd have an Apache or Nginx, and everything would be contained in our program, and it would call out to some kind of storage or database, and pretty much all of our code and logic would just be in one spot. Microservices is pretty much just chunking our application down. And you can, of course, have a hybrid type system where you have maybe 70% and you're kind of just replacing things in your application with these specialized services that are there. So the picture, we're pretty much the one on the right. We can set these up, however, so that they can trigger, they can call each other, they can conditionally do things, and run. Some attributes of microservices, because microservices is kind of becoming a loaded term, but we're really pointing at something that's a specialized service. So this may be something that just takes an image and it compresses it, and that's all it does. It pushes it out to the next thing and it's done with its job. Or maybe it only handles one route that's coming through and passes that off to a controller somewhere to do some logic. We're running on an independent process, so each one of the AWS Lambda has its own memory. So we can have a cluster of these Lambdas running, so all these different instances, but each one is spun up cold. It has a limited memory, and you have to pass messages to another thing or pull it out of storage somehow if you want to try to remember a piece of code. Most of AWS's stuff is done over HTTP, a concept that I think I read somewhere a couple of years ago from, I think, Martin Fowler, was this concept that came out of Unix programs of putting all the logic into your endpoints and just making a pipe to send data or to trigger the next Lambda that we want to run. So if you ever worked in Linux or Unix, you would run a program and the output would just be chained and spit into the next program, and that one would spit that out and go right into the next one. So that's kind of the concept, is keep all the logic in the Lambda. But the nice thing about breaking off of this monolithic style application is you can choose any language. You could have 5, 6, 10 different languages, all specialized for whatever specific task that you want to accomplish. and take advantage of when languages are really exceptional doing one thing, like maybe just using Erlang to run a bunch of parallel processes. So that's interesting. Some of the downsides, this is sort of subjective, but you do have additional complexity on kind of wiring all this stuff together and configuring, and a lot more passing credentials around and different types of things. A thing I believe is probably more important that could be a downside is when all of our code is in one place, we're only one function call away from it. We can just call over, we're one module away from it, we're one file away. When we're using AWS, this is all being pushed out into an HTTP call. So that adds a little bit of latency into our program and can add up depending on how we're putting it together. And sometimes the testing can be more complicated, especially if you start choosing a variety of languages to put into our application. Now we need to know 4 different languages rather than having everything run in Ruby or written in Ruby. Maybe we just write some C to extend it. Some things to think about when we're making our lambdas, which we'll get to here in a bit. We only have, well, we can set the timeout. Most of mine I set for 3 or 5 seconds, but this is really a stopgap just to prevent this thing from, if it hangs for some reason, it's not just sitting there holding it up. So you can set a specific timeout. We have a certain size for environment variables. This one's important. We can only handle 500 megs of zipped code, all total. So any libraries, gems that you want to use has to fit into this. And then it also gives you, AWS gives you a temp directory that, say you want to zip a file, you can create maybe a JSON file or something, put it into this temp directory, and then zip it up and then send it off to store it somewhere or whatever you want to do. But you do have access to that. Now that will go away. The documentation is pretty sketchy about this. They say you may have this information on the next call, but don't count on it. So I always just treat it as whatever you put in here is going to be gone the next time it gets called. So, but that's available. Here's a little bit of just a personal project that I'm doing, but hopefully it shows a little bit of kind of how something small would work. So these yellow circles are the Lambda functions running, right? So this guy, what it does is it calls out to Twitch's API. It says, hey, who's the top streamers right now? And then it calls out and says, hey, what's the top games that are being played? And it gets that information, throws it into an S3 bucket, and then and then this guy over here is calling, what is that guy called? Yeah. Okay, so this guy is pretty much just calling out to scrape out some data off of Google. So that one's actually just an Electron app, which is a way to bring Node into a headless server and go scrape up some data about the games or those particular gamers, scrapes up that stuff, bundles it, throws it into another bucket. But what's interesting is I found a gem, a package out there called Jets. Does anybody use Jets or heard of it? Essentially, it's a wrapper over top of AWS Lambda. And what's interesting, concept I never would have thought to do, but kind of clever. But it breaks out your routes. So we would have a traditional Rails project, and we would be looking at certain routes and calling different controllers and passing it back some views. But what this does is it uses an AWS Lambda for every route. And then that will call controllers, which also can be separate Lambdas. And I thought that was an interesting way to handle a server. So I have that one in the project that I'm currently working on. And this is the same project, but a little bit about the actual stuff that I'm using inside of it. So, I have Rails, or Ruby, that's calling Twitch. I got a Electron, and that N is Nightmare.js, which is a good JavaScript package for creating a headless browser, going in and ripping out data, which you can actually. The reason why I like that one is if you ever did any amount of scraping, a lot of times when a site will load, it'll put a default web page or a default image in the place, and then as the actual image comes in, then it'll load that. But if you write something that runs too fast, it'll run in, scrape out all the data for the pictures that are there and for the URLs, but all that's there is that default placeholder. So with this type of thing, you can say, hey, go here, look for this class name, wait a second, and then grab that, and so it just gives you a little more control, which is nice. And again, Jets can run, and I'm doing mine with React in the front end, and my project is just going to use D3 to do a real-time chart showing who's the most popular. And the only reason I'm doing this one is I'm interested to see kind of over different time zones, like what are the most popular games and streamers in Europe, and then as Asia hits its peak game time, what's popular there, and then it comes back around to North America. So this is the same project, but what this is doing is it's looking at the triggers. So something has to call our Lambda, which is nothing more than, in the same way that a function is just a block that contains code. And when we call that, we execute what's inside that block. So the Lambda is just that. But we need something to call our function, our Lambda, right? So Amazon gives us a whole host, and we'll check these out in a second. So the Twitch API is just running on a cron, so it's saying, hey, every 10 minutes, call that API and get what's current. The S3 buckets, which if anybody's familiar, that's just kind of Amazon's storage, a file type storage, so you can just a flat file storage. So as opposed to a relational database or NoSQL or whatever. So anytime that something goes into that, a file has been stored into one of those buckets, that triggers another Lambda to fire off. Of course, the front end, if anybody's going to the URL to a specific route, that's triggering and pulling back whatever the latest news item was. And then also there's a queue system, which is it's actually pretty nice and pretty intuitive. But you can push items into the queue, and you can just consume them on the other end by 10 at a clip or 1 at a clip. The only thing I did find is Amazon offers a SQS queuing system, which guarantees the first in, first out, but that cannot be used as a trigger for some reason. I saw that one, I'm like, well, this is perfect. It's going to guarantee me that they're going to come in the order that's sent. But for whatever reason, maybe in the future they'll reintroduce that as a valid trigger to be used. AWS has a lot of ways that you can write the Lambdas. The GUI is actually really good. I haven't found anything that I needed to go to the command line or that I couldn't do on the GUI, like from the command line. So I thought that was interesting. Normally the way it works is the GUI is limited or clunky. And some of these AWS forms, if you guys have used them, they really are scary as hell. I mean, you open them up and they got 40 tick boxes and columns and stuff that you got to write, and you have no idea what, which ones are optional, which ones are, do I fill in, which ones, if I hit the wrong thing, is it going to charge me, 20 grand next month. But the GUI, when you spend a little bit of time, it really does get pretty good. So of course the CLI is good. You can do these templates, so you can just have a YAML file, JSON file, and you can just spell out everything in these JSON files and just hit that and say, run this for me. And then also their development kits, the SDK kits, which of course we can pull that in, we can require it into our .rb files, and we can run those. So this is the one that we're actually going to look at today. So it kind of has the same elements as what you saw before, just a little more simplified. So we just have cron job kicking off, things are being pushed into a queue, they're going into buckets, all that sort of stuff, and then it just gets logged out. And so that's the end of that portion. So okay. So this is the basic. Has anybody used AWS? Maybe a third? Yeah, about a third. So when we come in, it has, when you go over to services, again, you just see this wall of things that are all services. And so we're going to go over to Lambda. Let's make this up. So I have this one called Basic. And does anybody know the Chrome key binding just to make it? Is that okay? Can you guys? Okay, we'll go with it. Okay, so when we go into here, so we're looking at, this is a Lambda function that's already made, but we have this configuration portion at the top. So that's showing the thing you click on here, which is the name of the Lambda function. Down here to this side is anything that we set up as our triggers. They all live in there. Then the opposite side is everything that we want, everything that we give permission to the Lambda to use different services. That all shows up on the right side. Below it, you see layers. Just a quick word about how AWS does the layers. Essentially, I bundled up my gems and I put them into my code that I uploaded for this Lambda. But what you can do is you can use these layers, and what it does is it makes an immutable gem. And so you can say require any gem that you would want, or series of gems, put them together with permissions on them, and name it as a version, and then any Lambda can use that. And then it doesn't have to be bundled up in your code. And one advantage of that is if you decide that you want to use their editor, which is in place, that's all right here. So a couple things to point out. So this is when we're calling our function. So this is called Lambda underscore handler, and then we have an event and a context parameter. And this is the name of the file. But if you look up at that top right, you'll see we need to tell this Lambda function where's the entry point, because we could have a bunch of files. And so the syntax for this is file name dot function name. And that's where it knows to enter in and then start. So the event, this first parameter, what that's going to do is it's going to bring in, that event will vary from, depending on what's triggering this particular function. So if it's a cron job, you'll get a different type of event than if it's something coming in a queue. You have a message in there. So it's just be aware that those will vary, and you'll need to decipher what's in that. They all come in as a hash, so you can parse it out. And the context is really just some context of your Lambda. You can actually ask it partway through, how long has this Lambda been running? And then maybe do something conditionally, like, hey, we've kind of used up too much time here, let's just get out of here and do something else, which is somewhat helpful. I'm trying to think what else is good to know on here. Oh, the thing that took me to the loft, the AWS loft. Okay, so the first thing I wanted to do was I wanted Postgres inside my Lambda. And what I didn't realize was when I'm running Postgres locally, Bundle will get that gem, it'll compile it for a Mac OS. And if I had a Linux machine running, it would compile it for a Linux OS or a Windows machine. And I didn't realize that it was doing different compilations for that. So I was essentially trying to push up code in binary set up to run on Mac OS. And AWS just uses their own proprietary Amazon Linux that everything runs on. So I was sending up binaries that were compiled for something completely wrong. So anyway, just something to be aware of. Anything that's compiled for a specific operating system, you can use it, but the answer is really to run a Docker image, you compile that down, and then zip that up with your code that you want to run, and then push that in. And yeah, but it was confusing because we really didn't know what things were failing, and the guy was really nice, but not very helpful. So we'll look at this on this side, just to give you some idea of what the other triggers are. This API gateway is all the any URLs that come in, any specific routes you can do through there, and that's what the Jets gem is a wrapper over top of, which is pretty nice. You can have it just set on logs, so anytime something is logged out, you can just fire off another Lambda in response. So when you're running your code, another thing to keep in mind is anytime you put a put statement, a P statement, or a print, those will all go into your log. And each Lambda has its own set of logs that everything goes out to. So everything that you put in there can go out, and then you can write a specific handler to look at those, parse them, and then say, hey, when you see error in this specific message, then call this Lambda function. Kind of nice. or can be helpful. And this just goes down the list. You can do it. Kinesis is a streaming type setup. SNS is for if you want to spam people with emails. That's the one you want. And and that's pretty much it for this guy. So we'll go back. So you can see this is the very first one they showed, letter A. If I hit this CloudWatch events, you'll see I have this cron that's set up, and I have it just disabled right now because it costs me money every time. You hit that, you hit save, and essentially this now just goes every minute and starts chaining this chain of events off. I'm trying to think of anything else that was interesting as I went along. Of course, there's another tab that just has the monitoring, and it'll show you these little green bubbles. They're barely coming up over there, but essentially it'll log. It's got a little real-time chart there. It's pretty helpful. Yeah, I think that's it. I mean, I was going to go through and open up all these logs just to show you everything running, but it's pretty much, it's just logging out these basic things. All this guy is really doing is, one is just looking up every holiday in France and Australia and England, and putting them all in a thing, picking a random one, and sending it out into storage just to go through these things. And yeah, AWS, their SDK documentation is really good, actually. It spells it out, gives you lots of examples. I guess I'll just finish on the one last thing that I thought was somewhat frustrating when I was doing this is AWS has very good permissions structure and security structure. So there's layers across everything. So I can write a thing and say, I give permission to every Lambda that I own to do this specific thing, to talk to a Postgres database. But I can also go very fine-grained and just say this specific user can authorize this. But what I find confusing is there's at least 6, 7 major ways to set up permissions, and they all live in all over the place, on the docs. And as you're reading through it, it's at least to me, I was just like, wow, this is very disjointed when you read through the docs or try to figure out how all this documentation works. And then they also have automated type things that you don't even know the value to the keys. They just auto-generate and renew every week. So maybe something like that would actually be the most secure, because it kind of just wraps all that stuff. Just puts a little sugar over top of it and makes it easier. We can just tell it what you want it to do and not have to get in there and do all the fine-grained stuff yourself. But yeah, we have a couple minutes, or we can do a couple questions if anybody's. Yes.
Can you do any sort of automated testing?
Yeah, I mean, it's, we can, of course, bundle up any of our tests in a Lambda itself and just have it run when we call it. The nice thing is you can also, I think one thing I left off is I mentioned a bunch of different triggers, ways to call other ones, but there's also just the very basic one of just your Lambda can just call another Lambda directly. So you can write your tests just specific for one Lambda and just run that uh, on a periodic basis. But maybe the one that you'd want to look for is they have if you're doing a continuous integration, every time you push up to prod or a specific branch, that is a set trigger in Lambda. So anytime you can tie that into GitHub and say, anytime you see this come in, GitHub will call over to the Lambda and then run whatever specific tests, and then only allow that to go into production if it passes all your tests. Like that.
That's pretty cool. So is there any idea of like environments? Can you like advance a Lambda from like one environment to another one, or?
I'm not sure what you mean by
Is
environments.
it like, did you have like a staging environment and a production environment?
Oh,
or would you have to like cut and paste the code to move them between the two, or that kind of baked in?
Yeah, that's interesting. As far as I know, there's only the Lambdas that are running live, or for whatever specific task you set them for. And within AWS, they don't have that structure. But of course, you could name them different things and name them after the branches, and only allow certain ones to go. When you push to that branch or something like that. But it would be something that you would do manually, or make several versions of your Lambda in your branches and then run them that way.
Cool. Makes sense. Thanks.
Okay. Oh, and they also have a setup that just came out kind of recently. That's essentially you just get this flavor of the Amazon Linux environment, and you can just run your stuff locally, but it's guaranteed to be exactly the same as if it was running live. So that gives you the ability to test all you want in a playground and not have it running on their machine. It could be your machine.
All right. Any other questions for Michael? Hands. All right. Please give a warm welcome applause to Michael.